everybody, this is Mr. Munson, and we are looking at Unit 2. This is circles, and sometimes students find this a little bit difficult. Some find it very easy. I'm hoping that you find it very easy. If you are struggling through this section, you want to come and get help right away. Don't wait till 5 or 6 things pile up on you, and then you're trying to figure out 5 or 6 things. There's a lot of different concepts in here. Stay with me, you'll do fine. Okay, so in this video, we're just going to simply unleash the vocabulary for this video. So I have taken, and you'll see the notes for that as I progress through this video, the notes and the words and all that stuff. This video, the answers, if you will, to your vocabulary is actually a document in the comment section. If you click on that, you'll see the document with the answers in it. So if you'd prefer to do it that way, you can go look at that. Otherwise, just watch through this video and add things as I do. Let's get started. Okay, well, let's start off with the word circle. Okay, so a circle, that arrow just reminds you to put the words on the other side. A circle is the set of all the points that are exactly the same distance from some given point, okay? So as you can look in the drawing, a circle represents all the points that are exactly the same length away from some given point. Okay, points out on this circle are the points of the circle. The center of the circle is not a point on the circle. It's just a reference point. So make sure you never say that. All right, next word is radius. It's basically the segment from the center of the circle to the to any point on the circle. Every radius has the same measure. So there's a circle with a radius drawn. Next word is the word chord. A chord is a segment that connects any 2 points on the circle. So if I take and put 2 points on the circle and connect them, that's a chord. Here's a chord as well. Right? Now, since it goes through the center, we have a special name for that. So a chord that goes through the center of the circle is known as a diameter. Of course, the diameter is twice the length of a radius. Here's a radius. If that was 5 centimeters long, then the other side of it is also 5 centimeters long, creating an entire diameter of 10 centimeters long. Congruent circles are 2 circles that have the same length radius. So if you think about it, here's a radius for the one circle on the left, and then going from the center of the other one in the other direction, we create 2 radii that are the same length. So those circles are congruent. Now I want you to add, a couple of blank lines. You can put C's at the beginning of it, and then on the other side write concentric circles. And concentric circles, and I'm going to do the drawing up a little higher here, but you can put it down below concentric circles. Here is 2 circles that are concentric. These 2 circles have the same center. Two concentric circles. Different radius, their radii, if you will, are different. One's longer than the other, but they have the same center. So the next step on the next page is secant. A secant is a line or ray or segment that intersects a circle in 2 and only 2 places. So here's an example of a secant. All right, next word is a tangent. A tangent is a line, array, or segment that intersects a circle once, only once, okay? The only way that can happen is if it touches the side and then skips right off of it. Next up is semicircle. Basically, a semicircle is half of a circle. So here's a semicircle right there. Now, if you look over to the right here, I have a semicircle, kind of that, area of the top of the circle that I have shaded in. Now, if I do anything less than that, it's still part of an arc. It's called an arc, or this is called an arc, and it's called a minor arc. It's less than 180 degrees. Now, the semicircle is 180 degrees. Remember, it's 360 all the way around the circle, and so that minor arc is it's something less than 180 degrees. So let's shade in that KC there as being the arc that they're talking about. Okay. Now notice that 2 letters are used to name that arc. Okay, 2 letters. Minor arcs always use 2 letters. And the reason I say that is because major arcs are always 3 letters. Okay, so now if you take a look at the drawing, it talks about major arc DEF. The fact that they use 3 letters tells me it's a major arc, and that's greater than a semicircle, or greater than 180 degrees. If I called it, if I had you looking at this drawing and I wanted you to look at this side of the drawing, the circle, that would definitely be greater than a semicircle, and I would call it DEF. Now we're going to be dealing with some vocabulary words of special type of angles dealing with circles. So in this case, I have a circle where the angle's vertex is at the center of the circle. That's called a central angle. This is, if you look at the drawing there, I have it highlighted in red, and next to it I have ROK representing the angle. Now an inscribed angle is an angle whose vertex is on the circle. Okay, so we take that vertex and we move it from the center out to the edge, and those 2 chords there going from C out to the sides are the sides of the angle. All right, now remember, an arc on a circle is some part of the edge of the circle there, right? So in this case, the vocabulary word refers to the part of the arc that is cut, right? If you look at the angle, it cuts that arc. Okay, so the angle comes out, it's an inscribed angle, and it cuts that arc. Next up is a formula, basically, and an idea that you've had for many, many years, and that's circumference. The circumference of a circle is the distance all the way around it. Okay, now we can't use the distance formula because the distance formula is used to calculate the distance of a straight segment. Now we're talking about a circle, and here's the formula. Okay, put that on your formula sheet. Remember, there's a left side and a right side. That allows for, if I give you the circumference amount, you could calculate and find the radius, because that would be the missing unknown. The symbol pi is approximately equal to 3.14, but you should have a pi key on your calculator. I want you to stay there with that pi key. Okay. Review that sample and make sure you understand how to use and take information from a circle and put it in for the circumference formula. All right, next is arc measure. So when we're looking at this arc, you know, this part that's cut by a, in this case, a central angle, that arc has a measure, and the measure is in degrees. Now, it's quite understandable that students would mess up circumference with a measure. They sound very similar, but the circumference is going to be measured in things like centimeters, inches, and things like that. The arc measure is going to be measured in degrees. Okay? As we go through this section, that will become more and more familiar with it, but make sure you understand that. Look at the drawing here, and you'll see that the angle TOY, I'm sorry, the angle TPY, I put a P in the drawing there, and I encourage you to do the same. The angle TPY equals 70 degrees. That's the way it's marked. And because the central angle that cuts this arc is 70 degrees, then the TY arc is 70 degrees as well. So that makes it really easy. These two are going to be exactly the same. The central angle and the arc are the same. Where it's different is this this 290, and that comes from what's left over to create the major arc on the other side. And that's going to, of course, be 290 because the two have to add together to give you 360. All right, next up is another formula. So now we have an arc length. So now we're back to kind of this concept of circumference. Circumference all the way around the circle is measured in inches and centimeters and things like that. The measure of an arc is measured or given in degrees, 70 degrees, 80 degrees, and all that stuff, 360 all the way around. So if I was looking for the length of the arc DE, I would use this formula. Okay, so if you look at the formula, and this is one that you're going to have to memorize, okay, and the more practice you get, write it every single time you use it in this section. Don't go and just write parts of it or whatever. What we find out is that the left side and the right side are fractions. And so there's this relationship between the arc. See where it says arc above the 360? It has arc in degrees. That's the arc measure. So arc measure, whatever that number is, over 360 is equal to the fractional amount of the arc length in centimeters, inches, whatever, as the bottom is in circumference. Okay? So we'll explain this formula in greater detail, and what you want to do is just at least know where this is at and how to find it. Put that formula on your formula sheet. Now the vocabulary word sector, it's part of a circle. It's the region of a circle like this that's created by, you know, a central angle going out and cutting out a piece of this circle. Okay, so it's a circle. It's a region bounded by two radii that are intercepted arc. I always look at this as like a piece of pizza, right? The whole circle is a pizza. That's a piece of the pizza. So when we're looking at circles, and I'm just going to do something over here real quick, I could ask you, what is the circumference of a circle, right? I could also ask you, what is the area of the circle? Area of the circle is basically how many squares it takes to cover it, okay? So that's area. When I'm looking at arc length, I'm looking at the length of just a part of the circumference. Now this next thing I'm looking at, I'm asking you, what is the area of just a piece of pizza from the whole pizza? This is called sector area. And that's the formula that you'll use to calculate the sector area. Put that as well on your formula sheet. All right. Hey, I appreciate you taking a look at the video. We are done with our vocabulary. I want to throw this bonus at you if you like. The bonus is for an angle bisector, okay? This is a construction. You're going to use compass and straight edge. There's plenty of videos out there where you can go and find somebody showing you how to do an angle bisector. What I want you to do is draw any obtuse angle on a piece of paper, okay? Then I want you to use a compass and a straight edge to do the compass construction for angle bisector. So Google angle bisector compass construction and watch a video, understand it, come in on your own, understand how to do that, bring it to class, and you got yourself some points. All right, take care. Have a fantastic day.